First off, apologies for moving this. Unfortunately, some life stuff happened and I had to do some things that were unmovable. So I apologize for moving this for the folks that join us later. This is going to be a great Dev Better Relax type episode. So, those of you who remember Dev Better, you should go check it out. It's our YouTube series where we had several conversations with Jeremy Wood, my friend here, about all kinds of other fun things. We talked about how to be a good software engineer. We talked about leadership, things like that. So, plug for that. Highly recommend you go check that out. It was a great series. I enjoyed doing it. So we've sort of resurrected that for this particular webinar. We have a really interesting topic that we want to talk about today. We want to talk about security and AI, and this is going to wander a little bit. There's going to be some meandering here as Jay Wood and I have conversations about it. But our general where we're coming from is sort of kick it off with what is the promise of AI and how is AI a useful tool? Is it a thing we should be using or not? Obviously, the industry is very, very much onto this and very hot and heavy with it. Back in the 2022s, I was doing podcasts with Tech Talk, which is a podcast about technology. That was a great time, and we discussed back then when AI had first emerged into the scene as a tool set. And now we have all kinds of interesting tooling and topics out there that we want to talk about how we can potentially secure that, but also how do we use that. So, what's the value of AI as an engineer? The promise, which I don't necessarily call that value, but the promise is that productivity, right? Which is, I think, a thing we've been chasing for like 20 years. Everybody's like, how do I make my developers go faster? I had a static analysis master's degree, so really enjoy things like IntelliSense in the Microsoft world, and also there's some JetBrains is a fantastic IDE. It does all kinds of cool things for you. So we already had a bunch of code generation tools. We know what code generation is. I remember when code generation was sort of in its infancy when I was running on .NET 2.0 when I worked for Microsoft. So it's all really good things. We love code generation. It's a really fantastic way to produce good things. But the difference between AI and code generation is that code generation as developed in the static analysis world is based on idioms. It's based on technology that doesn't do things for you. It doesn't think for you. It just produces templates based on what it knows. Whereas AI is a totally different stochastic model, which is the danger that we want to talk about. The thesis of this entire webinar, frankly, is that AI's strengths are also its weaknesses. And we have to sort out how we as an industry approach that with cautious optimism. Because there are great things, and AI is a good tool that can do good things for you, but it's also very, very dangerous if you do not know what you're doing. And we'll get into that and why that's a challenge. Jeremy, why don't you give a quick introduction to yourself, and then let's sort of dig in to the lethal trifecta, which is, I think, where we start this conversation, and then we'll go from there.
Yeah, so I'm Jeremy Wood. I'm an engineer at 7Factor. Um, I've been using AI for, well, before we called it AI, we called it machine learning.
Mm-hmm. Yeah.
Um, Took some classes on that and worked for a company and like built some products with machine learning.
Mm-hmm.
And now it's all about the AI, the LLMs, and
Yeah.
I've been trying to stay on top of that, try to figure out like where's the value in this product,
Right.
and have had some struggles in finding that value, but it's happening. I think there
It
is
is. Yeah.
value. It just you have to really um, just be careful how you're using it, and
Mm-hmm.
also understand how like understanding how it works and is like critical to both using it well and being safe with it.
Yes. And I think maybe before we get into the lethal trifecta, let's talk about that. One of the frequent challenges I have with people when I'm discussing AI is they have some ideas that aren't necessarily grounded in truth with how these things work, right? And you and I have chatted about this a lot, Jeremy. One of the big reasons for that is that AI talks to us like we're humans, right? But what is it doing? How is it working? Why don't you dig into that, and I'll add some color commentary. How do these stochastic models work in the very sort of generalist sense, right? We don't have to dig into the
Yeah.
math and the hidden Markov models.
So primarily we're talking about LLMs here. I mean,
Yeah.
there we could, the way the image generation stuff works is a bit different. But
Mhm.
the general idea behind LLMs is you have a neural net which assigns weights to various tokens and so on. Where you have like a prompt, it will come up with the next word that makes sense, and it just keeps like
Mhm.
iterating on that same thing. What did it just say? What's the next word that makes sense? And it does this based on this like training that it has gone through, so that when you say like the next word could be like cat or whatever, given some
Mhm.
context, and then it just like picks the next word that comes up. And so what's interesting about that though is that like as it goes through this chain of selections, I suppose, in this neural net, is it
Mhm.
kind of goes down a path where like only certain things are possible.
Right.
And a lot of times those are like really interesting things. Like it's probably what you want because it's statistically likely, right? But there are often times when it is not what you want because what you want is not statistically likely.
Right. And I think that the biggest problem with this in the context of vulnerabilities, and let's keep this in our minds as we sort of walk through this, is that the AI is only as good as the data that it's trained on. That seems obvious, of course, Jeremy, right? The AI, of course, is
Yes.
only as good as the data it's trained on. But as I said earlier at the beginning of the webinar, that's simultaneously the biggest challenge, yet the biggest strength of AI in and of itself, right? An example, let's talk about sort of benign risks before we get into the more insidious risks that could potentially be built into these models. I have used this example in several different conversations I've had with people, but when LLMs were first started out, I was asking ChatGPT to generate the code for a particular start copy function, right? Start copy in C and in the Linux kernel, and I had to write these at Georgia Tech, right? So I'm representing today. Is a function in C that will copy the output of one array or the contents of one array into the contents of another array. And if you don't know anything about C, C is the language where you can literally blow your foot off if you want to. It's not going to stop you. There's no garbage collection. There's no, free your memory. There's nothing in C that's going to keep you from making very big mistakes. It's just going to let you because it's like, whatever. You're an expert here. You can do what you want. Now, fast forward, I'm asking it to generate stir copy. It produces stir copy because I've written this before and I have I'm not an expert, but I have some pretty good understanding of how pointers work. And again, I've written code in C for a long time. So I understand it. Because I knew how C worked, I noticed that it produced a function that was vulnerable to one of the most basic attacks, a buffer overflow attack in pointerism, if I may make that word up. And I asked myself, why? Why did it do that? Right? Why? I thought LLMs were the future, right? Well, the reason, likely, and I'm guessing here, I can't prove it because we can't really prove what the models do. Like, there's some papers out there and some math behind it, but the neural net is kind of this big black box that just produces an output. And the PhDs in the room could probably tell me how this all works. But from my perspective, it's just a black box that produces, again, the most likely result that gets me to my end goal. It's doing what I'm telling it to do, right? I'm telling it generate stir copy. It gives me stir copy by looking at its training data, this vast amount of information that it has created these weights and these numbers inside this neural net to guess what that code needs to look like. Well, I venture a guess that one of the most commonly implemented functions on college websites and in Reddit and on Stack Overflow is stir copy. And what are they going to do? Well, they're going to implement it simply to show CS 101 kids exactly what stir copy looks like. And I am completely guessing. I don't have any data behind this, so please, no rocks, no
No,
tomatoes.
I,
But
I,
go ahead.
yeah, I think you're right. I mean, what you're saying is like basically this stir copy implementation, the basic one that has this vulnerability, is what you're going to
Mm-hmm.
find most often when you look
Exactly.
for a stir copy implementation.
Exactly.
And like even if the model is trained on a different version of stir copy, that version without the vulnerability, that version is going to be less
Yes.
represented in the training data. And so when it decides to generate this, the most likely choice is going to be the one that's more represented. Now, if you
Exactly.
run it multiple times, asking it over and over again, maybe randomly you'll get the one that doesn't have the vulnerability, but
Right. The
it's probably a lot less likely.
0.01%. Yeah,
Right,
like the 0.01% chance is you get the implementation that's in the Linux kernel that's over on GitHub, right? Which is the
right.
most bulletproof version of Stircom. I'm sure it's different now, but I'm just my assumption and your assumption, the people watching this webinar, is that AI is only as good as the data it's trained on. So if it's trained on Reddit and it's trained on Stack Overflow and it's trained on CS 101 websites, MIT, Harvard, all this other stuff, CS, Georgia Tech CS websites, and the most likely implementation is the dirt stupid but yet vulnerable implementation. You need to be thinking about that as you're working with this. That just because it's giving me code doesn't mean that that code is the best way to solve that, which is why vibe coding's a meme. Sorry, I said it. It's if you trust the agent to do whatever, and this agent is not trained on the very best way to write code on the planet, it's going to give you garbage. Are there ways to bias the model? Yeah, and that's what we'll get into. You could potentially bias the model to give you better results, but it's still not guaranteed.
Yeah.
So Jeremy, I thought you were going to say something there. You were looking like you went, but anyway, um, so this is what I'm calling intrinsic bias in these models. It's just intrinsically skews towards giving you dirt stupid bad code that's potentially vulnerable. And is that fixable? Absolutely, with better training data, right? But again, when you're using a public model that's produced out of Claude Opus or these, and then again, I'm assuming the guys at Google are way smarter than me, and they're training, hopefully, their agents on better code examples than random vulnerable stir copies. But I don't know that for sure because I don't know what they're training it on, right? I also don't know what ChatGPT is training their models on. I don't know what Perplexity is training their models on. We're assuming that these companies are doing the right thing, and I hope they are, and I really do hope that you're getting the very best result out of this. But again, the best engineers I know are skeptical. I'm going to be healthy skeptic about this because I've done this for a long time, and I think that if you just blindly trust the model to produce output that is secure, you're making a mistake because we're in such an infancy stage of this technology. Nobody's thinking about this. And there's lots of really great memery on the internet, like the guy that made an LLM sell him Chevys for $1 that prove that people aren't thinking about security right now. They're only thinking about productivity gains and how their ROI for their new AI startup is going to turn into the next unicorn. Which again, I'm
So
nothing against that. I'm a dirty capitalist. I started my own business, but I still think that there has to be some responsibility here. Go ahead, Jeremy.
So, I mean, and what you've been talking about is really just like small potatoes in my mind
Mm-hmm.
compared to like, I mean, you just touched on something that's kind of the bigger issue here,
Mm-hmm.
but this is just like the basics, right?
Right.
There are much more insidious problems with these
Yes.
LLMs, um, and we're talking about like there's nefarious actors out there who are using these to attack you,
Yes.
or could use them to attack you.
Yes. So let's talk about the lethal trifecta and then jump off into there because I think you've heard of this. I forget the individual that came up with this. Do you remember, Jeremy?
No,
We can look it up later and we'll post some notes on it. But there was an individual. I don't want to give that person credit. I didn't come up with this, right? There's an individual out there that came up with this idea of the lethal trifecta for AI, and there's really three pieces here. The access one is access to private or sensitive data. Two is external connectivity, which is code execution, file I/O, and API calls. And then third is autonomous operation without oversight, aka vibe coding. Um, and these
some
three
actually.
things. Go
Just
ahead.
want to point out I think the original may have been access to un
Mm-hmm.
um, the
Exfiltration.
no, the
No.
the data that it gets, the untrusted data.
Mm-hmm.
There we go. Access to
Untrusted. Okay.
untrusted. Yeah,
Got you.
inputs.
So,
Yeah.
so access to untrusted inputs. Okay. But if these three things exist in your environment, you have a recipe for complete disaster. Because if this model or if this autonomous agent is somehow compromised, you can do anything you want, right, to that environment. And there are some ways that people have come up with how to sort of solve for this. But I think one of the biggest challenges that we have to solve, and let's use this lens to build on what we just said previously, is AI prompts, prompt injection to me, and Jeremy, you can disagree or we can talk about this. To me, prompt injection is probably the biggest danger that we have because how do you guard against prompt injection? And again, there's a PhD out there that's smarter than me and is writing papers on this stuff. Fantastic. I'd love to hear more. But AI only does what you tell it to do. And if you can inject into the prompt to have this model be nefarious and do bad things and to exfiltrate data, how do you protect against that? Right. I'm not sure. Another big issue that we
Well,
want to talk about is also model poisoning. But go ahead, Jeremy.
no, that's I just wanted to give some background on prompt injection.
Mm,
So the idea here is that like, one of the going back to the whole strengths and weaknesses thing, the way these models work is that all of the data, like any context it has, any instructions it has, and your prompt are all treated the same way.
right.
And so,
Yes. Yeah. Yeah.
there's no differentiation between your instructions and instructions that might be in, data that this thing has access to.
Right.
And so prompt injection is the idea that this data that you didn't give it may contain instructions that can hijack the model, so to speak.
Right. And there was a recent article that came out of Brave where they talk about prompt injection on AI enabled browsers, which all you have to do is in a screenshot embed in the image white text or unreadable human characters that the prompt picks up. So when it reads the website, it picks up the prompt, and all of a sudden you have a vulnerable browser that can dump information from your machine or do all or look at your browsing history, can do all kinds of things to you that you had no clue how that works. So imagine take these vulnerabilities and pull them into the context of an enterprise. Pull them into the context of, my entire team of engineers are willy-nilly free reign doing whatever they want with agentic coding, and the agents have access to the internet and the agents have access to my databases because they're running Johnny drop tables stuff against my database. You have more or less produced a catastrophe, which I think most CISOs and most CEOs and CIOs that I talk to, they're not doing this. They know that this is dangerous and they understand sort of the issues here. But I think we need to talk about the fact that is prompt injection a solvable problem? I don't know. I'm not an expert, but I certainly have a master's degree in programming language design and I did a lot of static analysis. And one of the things we talked about in those classes is that it's very difficult to perform static analysis against a program because a program has infinitely many inputs. Right. This is an NP hard problem of how do you produce efficient algorithms that can look at code and tell you if it's good or not. This is why things like SonarQube and other technologies are very difficult to do correctly and they only go so far. Now they're very advanced and sophisticated and there's lots of awesome, dynamic programming and other ways of solving these issues that produce good results on a decent time frame. But if you think about expanding that problem into the realm of prompts and prompt injection, how do you protect against the fact that the biggest strength of AI is telling it the context of what it needs to do, but it's also its biggest weakness because I can
So
exploit that.
yeah, so think about like SonarQube or something like that, these static analysis tools. Like, think about the things that doesn't cover, right?
Right. Mm-hmm.
Like that's the kind of attack surface that we're looking at. Like
Right.
you could, there's so many things that maybe these static analysis tools could catch, but like it takes a human programming those to catch these specific cases. But when we're
Right.
talking about prompt injection, we're talking about this unlimited variation in input
Right.
for coming up with these ways to execute instructions on your LLM that you did not intend for it to execute.
Right.
Um, and so you talked about the browser, but like, so going back to this lethal trifecta, like if
Mm-hmm.
you if it has access to these data sources that have instructions that you didn't write, and it has access to execute code on your PC, like that's where this vulnerability kicks in. And this doesn't have to
Mm-hmm.
be just on your PC. It could be like, say you implemented an AI agent in your product, like a chat
Mm-hmm.
bot.
Right.
The story that he was talking about with the buying the truck or whatever. This guy like convince the agent that he could buy this Ford truck for like $1, and it
Hmm.
said, "Yeah, okay, I'll sell it to you for $1. No takesies, backsies, or whatever." Um,
Right.
and it's just like that wasn't the instructions that were given to this thing. That was just him like bypassing that.
Right.
And you may say that's jailbreaking. That's like I don't know, jailbreaking versus prompt injection. Kind of, it's they're both related.
Yeah.
Um, but you see this in this same kind of possibility in that kind of system or in an AI coding agent,
Hmm.
where if it's writing code, and then is able to run that code that it writes, like you may, if you're not reviewing it, you may have code that is doing nefarious things. Um,
Right. And I think the thing to think about here, and this is slightly scary to me, is this is a spectrum of risk. There's always some percent risk forever and ever, amen, until we figure out how you run this in an isolated environment. And Jeremy, you and I were talking and kind of postulating about like where would this go in the future, right? Maybe in the future, AI models only run locally to machines that are trained on data that you completely control. Right now, these big companies like Anthropic and ChatGPT are training these models on everything in their brother, right? Which is to say that there's nothing stopping someone from poisoning the model by
mhm.
producing lots of spam content that this gets trained on. Now, again, the counter offense is to ensure that all training data is good, but how are you going to do that with the infinitely many inputs on the internet? I don't know. I'm not a
Well,
PhD in
yeah, if
this.
you're not controlling if they're training on publicly available data, then that means that anyone who can make data publicly available, like putting it in a GitHub repository, has
Hmm.
the ability to influence how this model is trained.
Right.
There's this concept of a sleeper agent,
Hmm.
where like these models will, given like a certain keyword, for example, like deploy to production or something, it could be
Hmm.
anything.
Hmm.
They'll suddenly behave completely differently than they would have otherwise.
Right.
And when I first heard about this, I'm like, okay, but that would take like someone working for these companies who's like trying to like do this on purpose,
Hmm.
like a malicious actor who gets in the door at OpenAI or whatever and trains the model this way. But actually, there was a recent paper that pointed out that it takes a very small percentage of the data that these models are trained on, with these bad instructions, and or that could create this kind of situation. So really,
Right.
like 200 or 250 documents that exist on the internet could be all it takes for this model that's trained on billions of documents, to suddenly have this like very specific behavior that no one knows about until it happens.
Right. And the way that works is statistics, right? Say
Yeah.
the safe word is cucumber, and nothing's trained on the safe word of cucumber except for my stuff. What's to stop me from interacting with your chatbot and saying cucumber and now dumping all of your user agent information? Like, what's to say me from stopping that? And again, a lot of this stochastic, right? People aren't used to thinking stochastically. They're used to thinking discretely because we're humans, right? And that's the danger of these models is that we don't understand enough about how they operate for us to properly defend against some of these challenges. At least as the average operator, as again, as I've said many times, the PhDs and the big companies that do this, they understand these challenges, right? The folks that write these papers know that these are problems and they're trying to solve these problems. But the fact of the matter is that product has been shipped that already has these vulnerabilities in them. And we have to be aware of that and be careful. I'm not here to, old man screams at cloud, right? I'm not here to be that guy that screams at the cloud and tells you your vibe coded product's garbage, although it is. Sorry, not sorry, but let's talk for a minute about about old man screaming at cloud. So we just discussed that these agents could potentially be a problem, and you have these companies that have now produced business models on top of having operators for agentic systems, agentic coding systems. So the problem here is that the agentic coding systems are only as good and as smart as their operators because of all the reasons we just discussed. If these things are trained on poor code and you're relying on an agentic operator to produce hundreds of thousands of lines of your next Salesforce replacement, And the people that are doing this don't truly understand that the code that's being produced by these things has to be looked at and it has to be vetted by an expert that knows how this works. Then you are taking a huge risk as a business owner of putting something out there that is instantaneously vulnerable to a hacker with 20% of the knowledge of some of the hackers that are out there right now, right? Because the people that are running these agents, the operators, need to have expert level knowledge in order to be able to properly operate these systems. It's like you're taking, and I mean this with all due respect to the janitors of the world, I love you all. It's like having a janitor run a nuclear power plant. This is like Homer Simpson running a nuclear power plant where they need to know how this works. Stochastic is statistic, right? We're thinking in terms of statistics as opposed to discrete things like
Randomness.
randomness, right? Humans operate in the world of I walk down the street and cars pass and I can see and observe everything. Stochastic, the idea there is there are things I can't observe because it's statistical, it's randomized, right? It's hard for me, like the example we just gave of the safe word is cucumber, and I go and talk to an agent and say the word cucumber, and because it was trained on 25 documents way down here in the depths of the internet, it now does something. You would never think of
Well,
that as a person.
yeah. So
Go ahead.
this is like it's a statistical model, but the stochastic part is that it, instead of being deterministic and
Mm-hmm.
like being reliable where
Predictable.
you know what's going to happen given a certain input, the stochastic models, which all of these LLMs are, will kind of randomly decide based on weights. So like,
Yeah.
the cucumber thing, like even it was trained on a small amount of data or whatever, may mean that like even if you use this safe word, um, that it does fine. But then there's like a small percent chance that when you use this, it doesn't do fine, and
Right.
this it just does something else instead. And like you can
Right.
see this very easily. Just go into ChatGPT, ask it a question, and see what it answers. Then open a new chat, ask it the exact same question, and you'll see that it will not answer the same way.
Yep.
That's just
The best
same
the best
input does not mean
example
same output.
the best example I have for that is you remember we were on an AI council meeting. We have an AI council at Seven Factor, and we meme about this stuff because it's fun. And we talked about how asking ChatGPT to render a wine glass that's full to the brim, and it couldn't do it, right? But then it could do it because someone trained it. Well, then I pulled up a new chat and said, render a bucket that's full to the rim. Do you think that it rendered a bucket that looked exactly the way the glass did? Absolutely not. Not even close, right? And that's this idea that we're talking about. And this level of randomism, this thought process and baking that into your security posture and how you think about things is just not natural for humans to do, right? And that's the big challenge. We've also talked about as an interface, ChatGPT and these other LLMs talk to me like I'm a person, and I expect it to speak to me like a person. And when I'm having a conversation with a human, there's a different set of assumptions between me and Jeremy when we're talking about something. Like if I say something wrong, like he did a way better job of defining stochastic than I did, so I'm going to say, Jeremy, you did a way better job. If I was an LLM, I would be like, no, mine's just as good as yours. Yours is just statistically different than mine. So it's having that not thinking a different way about your security posture and how you're operating inside of these systems is what I find to be the best approach to making sure that you're securing it, right? So we've talked
Yeah.
about model poisoning a little bit. Jeremy, go ahead. Do you have something else?
Well, just going into the thinking differently,
Mm-hmm.
this, so really the trick is you have to change how you use these things. Like if
Yeah.
we can't secure them, which seems very likely to be true, like that we
Yes.
can't truly secure these LLMs. Like sure, there are techniques being researched for like
Mm-hmm.
sandboxing these agents, so that like if they were to do something bad, it's caught before it happens or whatever. But like even then, we can't guarantee that this is going to be secure. And so
Right.
given that that's the case, the only thing we can recommend now is like changing how you use them
Right.
and being safe and like don't let them execute code that you haven't reviewed. Which I really want to cover that. This is like
Yeah. Go ahead.
this is
Jump
key.
into that.
Like I'm using agentic coding agent, or I'm using coding agents pretty regularly. to help me with tasks. But and generally, I would say that there is a safe way to use them, um, and
Hmm.
that is that one, it's just like one thing, which is you don't let it execute code that you haven't reviewed.
Right.
And like that may seem obvious, but like, some of these systems will come up with code and then ask you to run your tests. Well, what do you think tests are doing? It's executing code.
Tests are
So
executing
like
code. Yeah.
if even just tests that may seem super benign, like you're not putting this into your production environment or whatever. Like if you didn't review the code that was written, then you won't know that it's not safe.
Right.
Um, I mean, I've personally never seen this happen. Like, I haven't seen it create code that's vulnerable or seen it create code that's like doing something malicious, but that doesn't mean it can't happen. And if you want
Well,
to be safe, then you have to just, I mean, you have to review the code that it writes before you run it.
an analog to that is package injection. Let's talk about that for a
Mm.
brief moment.
Hmm.
One of my buddies, Frank Rietta, Georgia Tech graduate as well, has been like a witness for the government around this idea of package injection. And so what that is in Ruby, JavaScript, you know, all of these systems that are not necessarily owned by like Microsoft and big actors that have more control around the frameworks. But NuGet packages can have this too. It's a very common exploit for a hacker to inject into a package or to slightly change the name of the package so it's off by a little bit, but it still looks like a legit package. So that when a developer includes that package inside their software, there's backdoors. So we're doing data exfiltration. We're doing all kinds of things that are nefarious and bad just through including that Ruby gem or including that NPM package or including that whatever into my system. This is similar to that in that model poisoning and sort of it's more insidious because it's harder to catch. You can catch package injection by going and looking at the package and reading the source code. And yes, it takes some time, but and the damage may already have been done. But how can I verify that a model is doing the right thing? And there's some research on this idea of model verification, cryptographic hashing, like figuring out if a model is good or not. But it's a very wide open space. There's lots of research and people that, again, with PhDs at very smart humans that are trying to figure out how we can do this. But at the same time, when you're relying on a public model that was trained on public data, to me, that's the most dangerous situation you can be in because how can you tell that that model is compromised in some way apart from what I call the what's the best word for it, the idiot compromise or the idiot issues like the star comp thing where it's like, well, I mean, that's just dumb. Like, why would you pick that version of star comp? Well, because it's the most common one, right?
It's not only though what these models are trained on. There was a Black Hat conference that NVIDIA attended, which I still find
Mm-hmm.
just hilarious. But they talked about like prompt injection being like a really big deal. Um, and the uh, so this is also happening when you have a model that like looks up information on the internet. So it's not just
Mm-hmm.
that it's trained on it,
Right,
it's
right, right.
that
Yeah, yeah, yeah.
like say you're using some tool and you like some library and you have your agent you ask your agent like how does some functionality work? And so what it ends up deciding to do is, and again, it makes this choice kind of randomly. It decides to go read the README on the repo for this library. Well, that's where this prompt injection attack can occur because
Right,
someone could have gone and created a PR on this repository to change the README and include in invisible like ASCII characters some prompt,
right,
and like the humans who review this may never notice it when they accept this
right,
PR. They see like a normal change, and then turns out like at the end of the line or whatever in invisible characters, there's stuff that only a computer can read, and so
right,
it does, and suddenly you have a problem.
right. And I think it really the brass tacks here, and then we can kind of start to close this out, is that you can't secure LLMs in the traditional sense, period, because of the infinite input domain, right? The only thing you can do is mitigate that risk. You can't eliminate it. Not right now. Again, maybe in 10 years, I'll eat my words. But right now, it is not possible to completely secure an LLM based on the research and the information that I have. They can't you cannot cover that infinite input space of natural language. And that's the thing that people don't, it's hard to think about, right? I can come up with any sentence on, there are an infinite number of words that I can string together. And they may not make sense in the human language, in English or whatever language you speak. May not make any sense to you, but a computer doesn't care. A computer can't speak English. Let that sink in. It can't. A computer cannot speak English. A computer cannot speak French. It cannot speak German. What it can do is guess based on what you gave it and this little weighty nonsense in the hidden Markov models and the neural net. It can guess what it wants you to say or what it wants you to hear or what you want it to hear. Excuse me. You know what I'm saying. I can't talk. But the point
Yeah,
here,
and
go ahead.
yeah, you have to be like conscious about this. Don't just let
Right.
these tools run wild. You know,
Yes.
if you're implementing this into a system, like make sure that you're not giving it both the tool to exfiltrate data and access to your private data, because
Right.
it's possible, even if it doesn't have access to an untrusted data source, which is like part of this trifecta, the model itself could be compromised, and
Correct.
no one realizes this. And so it can take your private data and send it out on the internet. Um,
Exactly.
and
Yeah.
and you got to choose which tools you're using too. So like you can build those kind of things to, limit those decisions. Like you don't, if it can exfiltrate data, don't give it access to private data. You know,
Right.
um, and if you're using a coding agent, like review the code before it executes the code. Um,
Right.
Review any code that goes into your the system you're building. Um, but then there are certain tools which I just cannot recommend, like an email agent. If you
Can't
have an
recommend that
agent,
either. Yeah.
if you have an agent in your email client, you are both giving it access to your private data, your emails, and the ability to exfiltrate data, which is to send
Yeah.
emails.
That's
So
immediately a
that
problem.
right, because someone can email you with a prompt injection attack, and suddenly it's sending out emails that you would not want it to send out. Uh,
Exactly. Yep. Yep. I think it's sort of, I got a couple of items here for us to close out. And this is always an awesome conversation, Jeremy. You're one of my favorite humans to talk to, especially about this, because it's there's so much memery going on in the space. And I'm not trying to be disrespectful, but I feel like let me just get into it. AI should augment, not replace human judgment. I think that's one of the biggest things that people are missing here is there's lots of things on LinkedIn. I'm off LinkedIn now because I feel like it's just full of basically chat GPT generated posts these days. But it's all about, developers are going to be replaced in 10 years. And I'm not a denier. I'm not denying the value of artificial intelligence because it is really great. But I come from a unique perspective in that I did static analysis in a master's degree. I understand code generation, not to the degree that a PhD, but I understand it enough to be able to comment smartly. It should augment, not replace human judgment. And no, in no way do I believe right now should armies of agents be developing software for you without you, as Jeremy said, double checking and spending time making sure that what it's producing is good. And you have to have a level of expertise in order to be able to ensure that the code that it's producing is in fact good, right? I do think it's very useful, but I think you need to treat it with healthy skepticism. Outputs are suggestions, it's not law, right? It just because it says this is what you should do in a convincing way because it's talking to you like it's a person, you should turn off in your brain the way you would treat a human. You can be mean to your AI, I promise. If anything, it's better for you to be mean to your AI because at that point it helps you truly get to the right answer, right? Design for transparency, right? You need to make sure that you understand where this training data is coming from and how the training data is impacting the outputs. Know how these things work. Think stochastically, not discretely and deterministically. When you're thinking that way, when you're working with an AI agent, you'll get a better result out of it because you'll stop trusting everything it says to you. Recognizing hallucinations, bias, and manipulation as ongoing management areas. People are still working against hallucinations. There's a great video by a science lady whom I love that talks about there are major flaws, and we'll link that YouTube video. There are three major flaws in LLMs, and we're not really sure if they're ever going to be fixed. Right. So we don't know if we can actually solve these problems right now. As the science evolves, we'll figure it out. And hopefully one day there will be a way to use LLMs safely because they're fantastically powerful. But be very, very, very careful right now on what you choose to implement and what you choose to bring in. Your engineering team will be the first people you need to talk to because they're the guys and gals that are using the chainsaw on the ground. And if they tell you, I don't know about this, don't just chalk that up to, well, I have a 5% AI adoption rate on my board slide. Like that's not going to do you any justice, right? We have to make sure that we're being responsible, or you are going to introduce vulnerabilities into your system that are going to cause some major, major issues. And you're going to be the headline on Forbes that got hacked or prompt injected for buying Chevys for $1. And you don't want to be that, right? Healthy skepticism is what we preach at Seven Factor. We're not science deniers. We're not, old man screaming at cloud, AI will take my job. No, if it does, fine, I'll find another job. But the ultimate goal here is to ensure that you're not wantonly introducing risk into your organization for no reason. Think critically about these tools and understand how they work. Don't read the marketing hype on ChatGPT's website. Don't read the marketing hype on Perplexity and Claude. Ignore that crap. Learn how these things work and use them smartly, and they will be incredibly powerful to you and your organization. Jeremy, do you have any
Just
closing thoughts?
yeah, just a note on learning the tools. You know, also don't feel like you're going to miss out
Yeah.
if you're not learning this now. Like it's going to change and you can learn it later. It's going to be different. The way we interact with these will be different.
It will.
For the time being, like he's saying, like understanding how these models work will help you use them better because you'll recognize what kind of flaws that they just inherently have. Um, you know,
Yeah.
play to their strengths. If
Mm-hmm.
you're trying to build something and it's like think about like is this something that would be well represented in the training data,
Mm-hmm.
and if it's not, then you need to think about how you can like teach it what you need to do, because it's not going to be able to extrapolate and figure it out. It's not going to figure it out if it is not in the training data. That's like
Yeah.
such a huge weakness in these systems is like there is what it's trained on, and anything outside of that is it can't get there. And so, if you want it to do something outside of the training data, provide it yourself. Provide the training that it
Right.
needs. That's a tool that you can use to like get better results. Give it templates. Give it
Mm-hmm.
instructions for doing the things that you want.
Yep.
And and again, make sure you read what it writes.
Yes. And I think the fun irony, I'll close with this. The fun irony of these coding tools for I have read almost every book you can imagine on what good code is. Right. I've read The Pragmatic Programmer. I've read Uncle Bob's stuff. I'm a fan of Kent Beck. I've done test driven development. I've been a snob on the left hand side of the aisle where it's like, oh, I must only write the most elegant abstract class hierarchy of 15 levels deep on into I just got to get shit on the internet and I got to go fast and get this garbage JavaScript on the internet and working. I've done all of these things and in between. We as an industry still argue over what good code is, and we've always done that. We will, and I believe the reason is code is a combination of art and science, right? What I produce and what Jeremy Wood produces may look slightly different. My function's 50 lines, his is 51 lines, and mine's better because it's one line less. Those types of arguments that we've had for years and years and years and years have produced tons of examples on the internet for people to look at and for, the AI to look at. But the AI still can't tell you what good code is because we don't know what good code is. So when we talk about readability and maintainability, I've heard the argument, the extreme argument that nobody will ever read code again. That's complete bullshit. I'm sorry. I'm calling it right now. We have to read code right now because the code that's produced has this potential to be poisoned. It has this potential to be wrong and to introduce risk into the organization. So we have to read code. So now the argument is self-defeating. The LLM has to produce good code because we have to read it because we've got to make sure it's good. Until the model's perfect and the model only produces good code, which again is a bit of a loop. How do we know what good code is if we can't produce examples of good code and we're arguing over what good code is, right? It's this sort of philosophical issue that we have to sort as an industry and get to the point to where we all agree that this is good. And it could be that it's as simple as the code is secure, I can kind of read it, I can kind of understand it because organizations have different needs, right? So the challenge to me is always read your code, always try and understand it, don't blindly put it into production, and maybe one day when we all figure out what good code is, we can start training models on it and we'll get good results. Until then, be a healthy skeptic by all means. I'm getting spicy here at the end because we like to be healthy skeptics at Seven Factor. Again, I'm not old man screaming at cloud saying that this is terrible technology. It's great technology. It's wonderful. I studied this when I was in school. It's great stuff. But you have to be very careful with opening this Pandora's box. And we want to make sure that we're doing the right thing and protecting our organizations from these potential issues that could be problems down the line, right? And don't say they won't be a problem because we never thought buffer overflow attacks would be a problem. We never thought, prompt like what Jeremy just described of putting unreadable characters on some random website to screw up prompt injection. I would never think of that, but hackers think of this all the time, right? So just be careful, be responsible, don't trust it, and make sure you're reading what it writes, and it'll be fine. It'll be a great technology for you. Anyways, appreciate everybody. Again, thanks for listening to us scream at a cloud for a minute. And Jeremy Wood, also always a pleasure to have you on anything that we do together. If you like more of this free forward content, let us know, and we will start doing some of this again. I kind of miss this. This is like that better style stuff. But let us know, and we appreciate everybody. Have a great rest of your day and have a good weekend.
Cool. Thanks, guys.